Hello, good afternoon, everyone. So, I am Pavid Maiti, teaching assistant of the course named Symmetry, Stereochemistry and Application. So, today's problems solving classes, we are mainly seeing that how we give that in confirmation name RS configuration mainly. And first, we have draw that configuration in Fisher projection, and after that, we have to nomenclature of this confirmation is R or S. So, to make that OH conformation to Fisher conformation. So if we seen like this molecule where that bromine is in the above the plane and hydrogen is the below the plane, and first we have to make uh, making the carbon number 1 2 3 4 like that. So after that giving the number of carbon atom, then we have to place this carbon atom and our that bromine and this hydrogen will be above and below the plane, so we have to give this to bromine and hydrogen in the OH plane, and like our hand, and like this 1 2 3 4 the main carbon, this will be vertical plane. So if we see this molecule where bromine is above, and if we write this molecule in Fisher projection, so this will be like that, our bromine and hydrogen. So if we goes this side above, so our bromine will be right hand side and hydrogen will be left hand side. So in that Fisher projection, also that bromine will be right hand side and hydrogen will be left hand side. So like this Fisher projection. So after that making that Fisher projection, then we have to that to make this comparison R or S, we have to given the priority wise number. Priority means where the molecular mass is highest. So this will be our highest priority, and after that this will follow to the lowest priority. So after that Fisher projects are done. So how we make that or OH conformation to Fisher conformation? So to making Fisher conformation, so first in a molecule like this, a lactic acid. In the lactic acid, there will be hydroxyl group and hydrogen which are placed above and below the plane, and this methyl and carboxylic acid group are in the plane. So we have to make this methyl and carboxylic acid. These are goes from our side, like it will be not in the plane, it will be below the plane, and OH H and H will be above the plane. So we have to rotate this molecule like 90 degree. What will happen, this methyl and carboxylic acid um, goes goes from our side, it will be below the plane, and OH H will be above the plane. And when we rotate, so this OH will be goes in left hand side and our hydrogen will be right hand side. So first we have to make rotate that molecule and making this that above and below the plane in that above the plane. So after that making, so now we have to make the bond in the plane. So we have to just making all the carbon in the plane, and after that we have to that chiral center and denote this chiral center as C. So we have to remove that C, and this will be our Fisher projection. So from this OH projection, so we are coming, this one is Fisher projection. So after um, so before we go to give the RS nomenclature of any OH conformation, there are some rules where to identify. Uh, First one, we have to identify a chiral center. Chiral center means where the four substituent will be attached are different. So this will be our chiral center. So like an example, in that chiral center, this four, like one fluorine, hydrogen, hydroxyl group, and methyl. So there will be four substituent, and these four substituent not are same. So there will be different four substituents. So this center will be our chiral center. So first we have to identify our chiral center. After that, if we have to give the priority wise, like in this example, the priority, if we give the priority of this priority of this molecule. So our fluorine, which have the highest molecular weight, so fluorine priority will be 1. After that, our will be hydroxyl priority, and methyl will be third priority, and hydrogen will be fourth priority. So in that OH conversion, this will be, so up to first we have to identify that chiral center. So this is our chiral center. After that, we have to prioritize that where the fourth substituent will be what fourth substituent attached, and the priority will be like their molecular masses. So after that, we have to see that our fourth priority is above the plane or below the plane. So if it will be below the plane, like if our fourth priority will be below the plane, and we show that our this mm, another three priority 1, 2, 3 are will be in the clockwise, then our configuration of that molecule will be R configuration. So similarly, if we see any other molecule where that mm, our first three priority 1, 2, 3 are in that anti-clockwise, and our fourth priority will be below the plane. So this configuration will be S configuration. And if we prioritize like 1, 2, 3, and our fourth priority is in the above the plane, so then that will be S configuration. Similarly, if the first three priority in the anti-clockwise and our fourth priority will be in that above the plane, then the configuration will be R configuration. So after that OH configuration, so after this OH configuration, so this molecule will be our R configuration. So then the next is how we make this OH configuration to Fischer configuration. So to make that Fischer configuration happen, so first I tell that we have to identify that chiral center. So we have identified already the chiral center. Then we have to give this the in the plane bonds we go this side. So if this in the plane bond goes this side, so then that will be and this on the dotted one above. So in the dotted one will be place that fluorine and methyl, and above the below the plane will be placed that OH and hydrogen. So if we rotate this molecule, like F will be goes from our side, then this OH will be in the left side. Our hydrogen will be in the right side. So after that we have to make this confirmation into Fischer confirmation. Then we have to tell that this configuration is R or S. So for after making this confirmation in Fischer, then that rule for to this molecule R or S configuration. So the Fischer there will be some different rule from that OH confirmation. So similarly, we have to first identify that chiral center, and after that we have to prioritize the molecule like in the molecular masses. So if we prioritize, and if we saw the in our that the first three priority are in the clockwise direction, and our that fourth priority, like in this molecule, fourth priority will be in that horizontal plane, then that configuration will be S. Similarly, if we see the first three priority in the clockwise direction and our fourth priority in the vertical position, then that configuration will be R configuration. So in this molecule, so if we are giving the numbering by the molecular masses, so fluorine will be first priority, then OH, then methyl. So 1, 2, 3. So these are going to counterclockwise direction. So counterclockwise or anti-clockwise direction. So, and our fourth priority, this one is hydrogen, and this in the horizontal plane. So our configuration will be R. So this is matching like that. And similar thing, if we show this, our molecule is first three priority is rotating anti-clockwise, and and our fourth priority will be in the horizontal plane. Then the configuration will be R configuration, and for anti-clockwise rotation, and if we show that our fourth priority in the vertical configuration, so that will be R configuration. So after that we have solving some problems. So in this problem we have to see that there we have to draw that Fisher projection first, and after that Fisher projection done, we have to determine this compound, that R or S configuration of this chiral carbon atom. So first we have to identify the chiral center. So in that molecule there will be, so the chiral center will be if the four substituent will be different in one center. So in this center, in this carbon center, there will be one methyl group, one hydroxyl group, and there will be one behind hydrogen is already there, which in the below the plane which are not showing here. So and there will be another group here. So total four center attached, four substituent attached here are different. So this will be our one carbon chiral center. Also, if you so seen in this position, there will be also one hydrogen in the below the plane, and there will be one OH here, and one carboxyl group is attached here, and there will be another group. So total four different center presents also in this center. So in that molecule we have that two chiral center are present. So after finding the chiral center, then we have to go to make this OH form to Fischer form. So from to make the OH form to Fischer form, so we have to first to numbering the carbon center 1, 2, 3, 4. I have numbered that carbon center. Then this one carbon center from that above we have to place. So like this. So methyl will be our first carbon. Then second one is this chiral center. Third one is that chiral center, and fourth one is COOH group. So after that numbering of this, then we have to place that substituent. So already we have placed this methyl. Methyl, which one is the first carbon? We have already placed methyl is first carbon here, and COO is the last carbon in fourth position. So COO is in the fourth position. So and what are present in the carbon center, chiral center 2? There will be one OH group and one hydrogen group, and OH group will be above the plane. So if we rotate this molecule, and if this planar goes behind from us, like far from us, so this OH will be in the left hand side. So we have placed in Fischer form. So this OH will be left hand side, and so if the OH is left hand side, so the hydrogen will be right hand side, like here. So after that, then what will be happen for this chiral center? In that chiral center, if this O is in the left hand side, so this will be in the right hand side. So in that Fischer form, so this OH will be placed in the right hand side here, and after that this hydrogen, so this will be placed in the left hand side. So we have placed the molecule. We have already done that Fischer carbon. So after making this Fischer carbon, then we have to giving the priority of this first, that in that center, carbon 2 center. So in that carbon 2 center, if you see this OH, methyl, hydrogen, and there will be one CC bond is attached here. So if we are giving priority number OH, so OH will be our first priority, and this CC bond will be our second priority, and methyl will be our third priority, and hydrogen will be our fourth priority. So if we rotate 1, 2, 3, so 1, 2, 3. So this rotation will be our anti-clockwise. So if this rotation is anti-clockwise, and our fourth priority in the horizontal, So from the Fisher rule, what will happen? So if our 4 priority is horizontal and our molecule is rotate anti-clockwise, so this will be our R configuration. Similarly, if we from OH, so now we have to check we have right that is this one is right or wrong. So we have to check from that OH comparison that what will be the um, what will be the conformation of this chiral center. So here one the methyl OH and this carbon center is attached. So our OH will be our first priority. Then this carbon center will be our second priority, and methyl is our third priority. So if we rotate this molecule, so this rotation will be our clockwise direction. And for OH rule, if we rotate the molecule clockwise and our 4 priority is below, so then that conversion will be R. So from OH to Fisher, all are matching. So this center we have drawn, so this will be right. So after that, the next carbon center. So in next carbon center, then we have to again priority wise. So this OH will be our first priority, and carboxyl will be second priority, and this CC methyl group will be our third priority. So if I rotate this 1 2 3, so 1 2 3 rotation, so it will be rotation will be clockwise direction. So if a rotation will be clockwise direction and our four priority is in the horizontal plane, so then our configuration will be S configuration. So then we have to check that in that OS from our what is my chiral center configuration. So in this OS from we have seen, so this will be our OH. So OH in the first priority, carboxyl group will be the second priority, and this CC bond will be third priority. And if you rotate 1 2 3, so the rotation in the anti-clockwise direction and our four priority is below, so this also is yes, so these two are matching. So this center we have drawn here, so this center also that we have drawn correctly. So what will be, so we have drawn that Fisher projection, so we have to draw this, and after that we have to tell this carbon 2 center will be R configuration and carbon 3 center is the S configuration. So So to make that, there will be some simplify rule to draw that uh, to make the OH conformation to Fisher system. So if in the so I am making some simple rule, like if we in the OH system we would draw from see the molecule from the left hand side, and we want to try to draw this molecule from the left hand side, and so you have to giving that starting numbers from the left hand side, so 1 2 3 4 like that. So if we're giving the numbering from the left hand side, and the first chiral center if the substituent in the above the plane in this, so this one is the first chiral center, and if the substituent will be above the plane, so in Fisher what will happen, so in Fisher we directly giving this OH in the left hand side. So we have to remember in ways from we are starting the numbering from that left hand side, and if our substituent is placed in first chiral center in the above the plane, so in Fisher it will be in the left hand side. Similarly, if in the ways from we drawn from the left hand side and we already placed our first chiral center substituent in the Fisher system, for the next chiral center, what that if there's any substituent are present, what will be the position in the Fisher? So then the position in the Fisher, if you will in the above the plane, so then the position will be in the Fisher will be in the right hand side, and if this was in the below the plane, then in the Fisher this will be in the left hand side. Like similar, if this so first chiral center, what will happen? We were giving numbering from this side 1 2 3. So our first carbon is here, and after that this will be our carbon 2 center, the first chiral center. So first chiral center I have already told, if this OH in the above the plane, so we have directly placed this OH in the left hand side. So I have already placed in the left hand side, and after that carbon 2 center, what will happen? If will be in the above the plane, we placed in the right hand side. If it will be in the below the plane, so this we place this carbon in the left hand side. So if you draw any molecule anywise from the Fischer conversion, it is simple. So if you draw like in a molecule, so and we start from numbering from the left, starting from the carbon center from the left side. So the odd number will be, so this 1 and 3, any odd number is coming, and where the substituent are placed in the above the plane, so this will be in the left hand side, and any even number where the substituent is the above the plane, so this will be goes in the right hand side. Similarly, if it is in the below the plane, so it will be placed right hand side, and after that it will be placed in the left hand side for the next chiral center. So after this, so now we have to similarly we have to find out that Fischer projection. So first we have to draw the Fischer projection. So to making Fischer projection of this molecule, so first we have to give the carbon center name. So this will be carbon 1, carbon 2, carbon 3, and carbon 4. First we have to give the carbon center name. Then in Fischer also we have draw like this. So there will be 2 chiral center. So we have draw 2 chiral center, and from the numbering wise, so here I have to give the number 1, 2, 3, and 4. So then I have tell that if we starting from this left side and our first priority in the above the plane, so this will be placed in the left hand side. So just to remember this thing, so we have to directly place this OH in the left hand side. So OH is the left hand side, then what will be the hydrogen? So hydrogen is coming here. Right hand side. So after that I will tell that in that next carbon if above the plane, so this goes into that this side, right hand side. If it is in the below the plane, so this will be in the left hand side. So it will, this OH is below the plane, so this will be left hand side. Now we have to find out that this configuration is R or S. So first we have see this center, this chiral center. So in this chiral center, that OH will be our first priority, this CC bond will be our second priority, and this methyl is our third priority. So if this will happen, and if we rotate this molecule 1, 2, 3, so this rotation is counterclockwise or anti-clockwise, and our fourth priority is in the horizontal. So if that will happen, so our configuration will be, this one will be our configuration. For the next carbon, so if we are given numbering 1, this one also 2, so this one COOH carbon. So this one, so for this, so COOH will be second highest priority, 1, 2, and this CC bond will be our third priority. And the rotation of the molecule will be 1, 2, 3. So this rotation is also in counterclockwise, and our fourth priority in the plane. So our configuration will be R. Now we have to check. So we have draw this molecule in Fischer, and we have tell that these two are our configuration. So to recheck that molecule, So we have to just check that in our OH confirmation what are the chiral center are R or S. So in that first carbon, so this will be our first priority. This is our second, and this one is third. So 1, 2, 3. So these are going to the clockwise direction, and our fourth priority is below for OH rule. So this will be our R configuration. So this chiral center and this chiral center matching. So we have drawn this chiral center correctly. Now the next one. So for next one, this OH will be our first priority. This carboxyl will be our second priority, and this one will be our third priority. If you rotate that molecule like this direction, so this will rotate in the 3. So this will rotate anti-clockwise direction and our fourth priority anti-clockwise, and our fourth priority is above the plane. So I have tell already, if we rotate in a molecule and our fourth priority in that above the plane, then this configuration will be R configuration. So these two are right. This molecule, two carbon center will be R configuration like this. So this molecule name was 2R3R 2,3 3 hydroxy butanol. So this carbon 2 and carbon 3 both are in R configuration. Next, we have to find out similar thing for this molecule also. So first we have to draw that Fisher projection. So for drawing that Fisher projection, so there will be number of chiral center here is 3. In first two example, our chiral center first 2 chiral center are present, and in this molecule 3 chiral center are present. So we are making 3 chiral center here. After the 3 chiral center, then we have to give in the numbering. So this will be our first carbon, this one second, this one is our third carbon, this is fourth, and in the fifth position carboxyl group. So in the first carbon, that above will be methyl. So we have placed methyl. So now we have to place this substituent, and that, so I have to first give the numbering. So this will be 1, this one 2, 3, 4, and 5. And 5 there will be attached carboxyl group. So this one is COOH. So we are giving place there's carbon 1, 2, 3, 4, 5 like that. After that we have to give the numbering, and after that we have to find out the chiral center. So there will be 3 chiral centers. So this one is also chiral, this one is also chiral, and this one also chiral. So 3 chiral center here. So in that first chiral center I have already tell, and if we are starting the numbering from the left side, and our first in the first carbon are substituent placed in the above the plane. So this will be placed in the right hand side, and in that above the plane what will present CH2H. We are giving this number CH2. So now we are here. So we have already placed this CH2H here in that chiral center. So after that, so in that another position, there will be one hydrogen group. So after that we have to giving that this position in that position. So I have tell that first position in the first position the CH2H group. If the CH this in the first we have starting the numbering from the left side and our first priority in that above the plane, so then that will be placed in the left hand side. And for the next carbon, if also this all will be the above the plane, that then that will be placed in the right hand side. So it will be placed in that right hand side. After that, what will be placed for that chlorine? So chlorine also in that odd number and it will be in the above the plane. So chlorine are placed in the right hand side. So there will be H. So now we have to give that confirmation comparison is R or S comparison. So for this chiral center, so in this chiral center what will be attached here? One CH2OH, H, one CCCOH. So what will be, so after that CH2OH is present and here after CO is present. So this will be our first priority. This will be our second priority and this methyl will be our third priority. So and the fourth priority in the horizontal and our molecule is rotate 1, 2, 1. This is 2 and 3. So this will rotate our molecule in that clockwise direction. So our molecule is rotate clockwise direction and our fourth priority in the horizontal plane. So our configuration will be yes. So this configuration should be yes. So now we have to check. So we have things are right or not. So if we want to check here, so what will be the, this carbon center will be our first priority, this carbon will be our second priority and this methyl will be our third priority. So and if we rotate 1, 2, 3 anti-clockwise for priority in the below, so this are hydrogen, so it will be in the below the plane. So then our configuration, so this configuration will be yes. So these are matching. After that for the next chiral center, in the next chiral center this OH, so this one will be our first priority and in between this there will be attached some CH and CH2OH and here it will be attached CH CCl. So it will be the second highest priority. So this CCl bond, so because this there will be CCl and there will be CH2OH. So CCl bond at the higher molecular masses. So this will be the second priority and this one will be a third priority. So 1, 2, 3. The direction of rotation is 1, 2, 3. So also this direction is rotate in the anti-clockwise and our fourth priority in the horizontal. So this will be also S configuration. Now the next one, this carboxyl will be our first. This chlorine will be our is the first priority. Carboxyl will be our second priority, and this will be third. So if I rotate this molecule 1, 2, 3, anti-clockwise rotation or fourth priority in the horizontal plane. So this will be R. So what will the comparison? The first chiral center will be S, second one will be S, and third one will be R. So now if you are seen that what will happen. So in that, so we are given this carbon 4 center will be R conformation. So now we have check here it is right or wrong. So this COOH will be, so this chlorine is our first priority, this one is our second priority and this will be our third priority. So if we rotate this molecule 1, 2, 3, so this rotation is clockwise and our fourth priority, this hydrogen will be below the plane, and clockwise rotation in the OH front, and fourth priority is below, so that configuration will be R configuration. So it will matches. So this one matches, and now for that middle one matches or not. So for middle one, our CCl bond will be our first priority, and this CC bond, so COH will be our second priority, and this will be our third priority. So if this the cases, so if I rotate now, so this OH will be our first priority, this CCl will be our second priority, and this one will be third. So 1, 2, 3 rotation was anti-clockwise, and our fourth priority is in the below the plane. So then the confirmation is S confirmation. So this also matches. After that, this next example. So here also number of chiral center 1, 3. So just after seeing this molecule, so we have seen that molecule in that left hand side. So I will tell if we seen that molecule from the left hand side, and our first priority in the first chiral center, our Cl is in the above the plane, so it will be placed in the left side. What is the case for the second Cl? So second Cl is the above the plane. So for if the number is even, and it will be above the plane, and we are seeing from the left side. So second carbon, it will be the right side. So what will be happen for the last carbon? Third carbon. Third carbon is the Cl. If it is in the um, above the plane, so it will be placed left side, but it is in the below the plane, so it will be placed in the right side. So I will tell that if that carbon center number is odd and it will be above the plane, then that will be left side. And if the carbon number is odd and it also placed in the below the plane, so then that will be our right hand side. So now we have to given the numbering wise. So this will be 1, 2, 3, 4, and this one is our fifth carbon. So in that first carbon, what are placed? These are methyl, and after one Cl there will be one hydrogen is placed here. It's also one hydrogen, and here also one hydrogen. There is COOH group. So from this OH conformation, we have drawn already our Fischer conformation. So now after Fischer projection, we have to give this configuration is R or S. So for this, this chlorine will be the highest molecular mass. So this will be first priority, and this one CCl bond will be our second priority, and this CH3 will be our third priority. So what are the configuration of this molecule? So 1, 2, 3. The direction of rotation is clockwise or anti-clockwise. So this direction is anti-clockwise, and our fourth priority is horizontal. So what will be confirmation? So confirmation should be R. So now I have to check from the OH I have draw that right or not. So from the OH, so this CCl bond will be our first priority. This one will be the second priority, and this one is our third priority. And the direction of rotation 1, 2, 3. Fourth priority is the below the plane. So fourth priority is below the plane, and our direction of rotation is 1, 2, 3. So our configuration will be our configuration. So this one matching. So first carbon what we have drawn here. So this also matched. Now for the next carbon. So for the next carbon, so then again we have to give the priority. So this chlorine will be our first priority. Now what will happen? This one second priority or this one second priority. So here is attached one CCl bond and COOH. And here attached one CCl bond CCH3. So which masses are COOH is are. So this will be our second priority. And this will be our third priority. So first, second and third. So direction of rotation 1, 2, 3. Direction of rotation is in the clockwise direction, and our fourth priority is in that horizontal plane. So configuration of this will be yes. So now we have to check here it will be yes or not. So this one will be our first priority. This CCl bond, so this side will be our second priority. And this is side will be our third priority. And our fourth priority is below. So now direction of rotation is 1, 2, 3. So direction of rotation here anti-clockwise. So anti-clockwise direction of rotation and our fourth priority is below. So from Wedge rule, so this should be S configuration. So these are matching. So first two are matching. So first two center we have drawn here is right. Now for the next one. So for the next one, so this CCl bond will be our first priority. COOH will be so COOH and here it is CCl. So which has the higher molecular mass, CCl or CO? So Cl at the highest molecular mass. So that this one will be second highest priority and COOH will be third highest priority. So 1, 2, 3 direction of rotation is in this side. 1, 3. So direction of rotation is counterclockwise. And our so these are counterclockwise and our fourth priority in the horizontal plane. So this will be also our configuration. So now we have to check from here it is right or wrong. So if I check from here, so this will be first. This CCl bond will be our second, and this COOH will be our third highest priority. So if we rotate this molecule, so 1, 2, 3 direction of rotation 1, 2, 3 direction of rotation is counterclockwise, and our fourth priority is above the plane. So it will be our confirmation. So these three center all are matching. So this should be our configuration. I've seen. So this answer also right. So our carbon 2 will be 2R. This one will be R. Middle one is S. And carbon third like this one. This one is our configuration. Now for the next similar thing we have drawn. Same thing. So first we have to draw that fissure. Now we have to give him the numbering. This one is 1. We are always drawn from the left side, so it will be easy. 4, and this one is 5. For 3 chiral center here, in the first there will be COOH. So here also COOH. Fourth and carbon fifth position. Are placed. So I have tell in the next carbon if it is the above the plane, so it will be left side. If it is in that below the plane and if the number is even, so it will be also in the left side. And if it is in the above the plane, number is even or odd, number is odd. So it also in this side. So this one also Br. So now what are expect present hydrogen? So all 3 position is hydrogen. Now we have to find out this configuration is these 3 chiral center which are R and which was S. So for that, so we have to given the priority. So this one will be first priority. Change the pen color. Pen color. So we have to give the numbering. So this one will have first priority wise. So now this CCl bond. So this will be our second priority. COOH will be our third priority. So the carbon center rotate 1, 2, 3. So direction of rotation is counterclockwise. So direction of rotation is counterclockwise. So and fourth priority is horizontal. So this will be R. So now we have to find out here it is right or wrong. So our first priority was this one, second priority was this one, and third priority is that one. Now we have to rotate 1, 2, 3. 1, 2, 3. Direction of rotation is this, like clockwise direction. And fourth priority hydrogen is in the below the plane, so this will be R. So first we have drawn it is right, and this also R, it is matching. Now for the next carbon we are given, so this will be first priority, and here what is at as C Br COOH, and here it is at as C Br CH. So this will be highest priority. So this will be second for these cases. For the middle carbons, this will be a second priority, and this will be our third priority. Now rotation 1, 2, 3. So rotation is this also rotate anti-clockwise. So if your rotation is anti-clockwise, so the configuration will be R. Now I have to check here it is R or not. So this one will be our first priority. So CBr COOH. So this will be second priority. CBr this thing. So for these cases, there will be two in that middle center. The two center are similar. So this should be R, S, or anything that will be happened. Center. This one is that this center is one is the meso center, like this now. There will be one sigma plane is passed from here. So we check this 1, 2, 3, the direction of rotation, S or R. And for the next cases, this one will be our BR, this one will be double OH, and this one CL bond. So this one next, second, and this one is third. First, second, third. The rotation is counterclockwise, and so this will be S. So now I have to check here it is S or not. So if I check, so this one will be first, this one is second, no, this one is second, and this one is third. So if I rotate this molecule 1, 2, 3, so rotation is clockwise and 4 priority is below. So this will be first, second, third. So first, this one will be second and third. Rotation is anti-clockwise. 1, 2, 3. Rotation clockwise. So this will be R. So this will be R. So this one will be anti-clockwise. So this also R. Middle carbon is also R or S. Two are possible. So for this one denoted as like 3S. If you have shown here, so this one is so now the system is for that alene molecule. So for the alene molecule, we have to find out, determine the absolute configuration. So first we have to draw that molecule in that Fischer system like. Then we have to tell this configuration is R or S. So for alene molecule, if you have seen this molecule, so we have to first rule was we have to see that molecule from the plane of the side. So these are in the plane, and this hydrogen is the above the plane, and this methyl is the below the plane. So if this is the cases, so now you have seen from this side. So if you are seeing this molecule from this side, so what we'll see? So we have seen this methyl will be above. So this methyl will be above. So we have placed this methyl is above. Now if we have seen here, our hydrogen will be below. So we have given hydrogen below. Now we have to, in the first cases, we have to give the numbering. So we have to give numbering 1 and 2. So this will be our first priority. Now the second one we have to place. So our hydrogen. So this will be, if we seen from this side, so our hydrogen will be right side. So this one is the right side. This one is right side. And CH3 will be in the left. So if we place hydrogen is right and CH3 in the left. So you have already placed this one. So now we have to priority of this. So this will already we have given this first and second priority. So now for this sketches, so this will be third and this will be fourth priority. Now we have to rotate the first, second, third. How was the rotation? So first, second, third is the rotation is like this. second, third. The rotation is like that. So if the rotation is like that, is clockwise or anti-clockwise, so this will are clockwise rotation. So if the rotation is clockwise, so then this configuration will be R configuration. So what are the rule? So if we are seeing the molecule from the place in the plane side, we place our eyes from that plane side and if we place that molecule. So if we first we have saw this center, so we have to priority of giving the carbon center this one, then next center, so then we have to give the priority the next carbon. So this will be our first second priority. If this here it is methyl hydrogen all are same. So what then we have to give that priority from which side we have seen. So from this side we have seen, so we have to priority this one first, this one second, and then for this third, fourth. Now we have to see what are the rotation of our molecule. Is clockwise rotation or anti-clockwise? If it is clockwise rotation, then that will be R configuration. If it will be anti-clockwise rotation, then this will be S configuration. So now the next example one. So now this is the phenyl cases. So this also this chirality I have already told in earlier cases. So this one will be our axial chirality. So here no chiral center are present. Earlier cases, in one chiral center, there will be 4 different substituents are present. But now the cases is there will be in a axis, there will be 4 different substituents present. So this will be our axial chirality, and axial chirality is generated in the alanine system. And if there will be any system is present, there will be bulkier substituent are present like this biphenyl ring. So there will be bulkier substituent present, this methyl, this NH2. So for this steric rotation, so these are not in the same plane. So this will be in the plane and this NH2 is in the above the plane and this methyl side is the below the plane. So if like this cases, so this molecule also chiral molecule. So here the chirality is generated due to axial chirality. So now we have to draw on this molecule like to make which this configuration is R or S. So we have drawn like that. So we have seen. So we have placed our eye from here. So what we are seeing. So if I place this eyes here, so we are seeing that this NH2 will be above side. So we placed this NH2 above side. Methyl will be below side. So after drawing this, we have to priority of this two substituent. So if we are given priority, so this will be our first priority and this will be our second priority. Now what we'll see? Now we have seen that if we seen from this side, so this one is the right side. NH2 will be in that right side and methyl will be in the left side. So right side will be NH2 and methyl will be left side. Now we have to given the priority. So 1 to priority we have already given. So the next priority will be 3, 3 and 4. So now we have to, the rotation was clockwise or anti-clockwise, first, second, third. The rotation is anti-clockwise rotation. So anti-clockwise rotation, so the configuration of this molecule will be S configuration. So the configuration of that molecule will be S configuration. So this will be right. So if I summarize all of these things, so in today's classes, what we have seen. So first we have um, seen that how we will draw that wedge configuration to feature configuration. So to making any wedge configuration to feature configuration, so we have to give the numbering first. Then we have to shift which side which substituent present, and we have to place the above the plane and below the plane in the horizontal plane, and this the main plane in the vertical plane. So now we have to give in the number wise 1, 2, 3, 4, and in the carbon chiral center what are the placed. Like similar things if we are seen here. So our Br will be right side and hydrogen will be left side. So what are the situations? So first we have for any molecule from Fischer from OH conformation to Fischer conformation configuration. So we have to plane the in the plane molecule will be in the below side, and out of the plane we have to give in is right hand side or left hand side. So this will be above right or above left. So like that. So after that we have draw all that line, and after that we remove this carbon center. So after that, we have to know that how we'll give that nomenclature R or S. So for R or S nomenclature for that wedge confirmation, so that the rule was like that. So first we have to identify the chiral center. Next we have to find out uh, we have to priority of that substituent what are present in the chiral center, and then next find out that our four priority is above the plane or below the plane. If it is below the plane and our the first three priority are rotate is clockwise will be, then the configuration will be R, and if it will be below below the plane and the rotation is the anti-clockwise first three priority, then that will be S. Similarly things for the anti clockwise rotation, our four priority will be above, then that will be S configuration. And if the rotation is anti-clockwise and our four priority will be in the above the plane, then that will be R configuration. Next thing for that RS nomenclature for the Fischer system. So for the Fischer system, so these are not same like that ways. So for the Fischer system, so the place of that above and below the plane always in the horizontal plane. So we have to give him the numbering wise the horizontal plane. So horizontal plane side, if a carbon is placed or for priority, so now we have to check that rotation of the first three priority is clockwise or anti-clockwise. If the rotation is clockwise and horizontal plane place our fourth priority, then that will be S configuration. And similar things for the rotation is clockwise, fourth priority in the vertical, then that will be R. So and similar case for that like rotation is anti-clockwise rotation and fourth priority in that horizontal, then that will be R configuration. And if the rotation is anti-clockwise and fourth priority in the vertical, then the configuration will be S configuration. So this one will be S. So this should be S. So now we have to draw that molecule. So draw that molecule, I have simplified the rule. So like for the simplification rule was like that. So if I draw any center from west to that fissure from. So what we can do directly? So directly we are drawn from the left side, and if I place see that our in the chiral center it is in the above the plane, it will be left side. So seen from left side, the first center will be in that above the plane, so that will be placed in the left side. If it is in the below the plane, it will be placed in the right side. Similar for the next carbon, if it is placed in the above side, it will be placed here, its placed will be right side. If it is below the plane, its placed will be left side. So like simplify, more simplification, like if the number is odd and R in the chiral center number is odd and it is in the above the plane, it will be placed in the left side. So these are matching. So this number is odd, number 1, it will above, so it will be placed left side. And the even number cases, for even number cases, if it will be the above, so it will be placed in the right side. So even number cases, this one is above, so it will be placed in the right side. Even number cases, it is below, it will be placed in the left side. So after that we have drawn from that fissure to uh, wedge conformation to fissure conformation. So from this wedge conformation to fissure conformation, we have to first draw this line first and numbering this 1, 2, 3, 4. Then we have to place this wedge position and this wedge position. So it will be number is odd and it will be above the plane, so it will be left side. Number is even below the plane, so it will be left side. In the next example, what we are seeing, we have to also draw that fissure projection. The chiral center here is, in the first two cases, the chiral center is 2. Here the chiral center is more increased, so nothing to happen. So what will happen? So we have to just draw. So the above one will be left side, above one will be even number, so that will be placed right side. Above odd will be placed left side. Then the next thing, so now we have to find out the rotation 1, 2, 3 is R or S comparison. So I have already discussed this. So now for this next one, this also. So first I have to draw that fissure. So there will be 3 carbon center, so 3 chiral center. So it will number is, this number is odd, so odd, and that placed in the above the plane. So this will be like that. This number is even and this will be above the plane. So this will be placed here, and this number is odd, but it will placed in the below the plane. So this will be right side. So now we have to place, this one is methyl and now this one is COOH. We have to given the priority. So this one is methyl, this one is CCl, first priority, this one is second priority, this one is third priority. So now the rotation is like that. 1, 2, 3. Rotation is like that, and this will be our hydrogen. Is 4 priority one in the horizontal plane. So the configuration will be rotation is anti-clockwise. So this will be our configuration. So now we have to check it is right or wrong. So by checking from this side. So this one will be first, second, and third. Rotation is clockwise. So R. So these are matching. So like that we have to done. So similar thing for these cases also we have already done. So now for that Allen cases, so the chirality is generated for the axial chirality. So for the axial chirality, the not the plane, the chiral center, not the center one. So this will be in the axial position. So for this, we have to find the configuration. So we have to first see the molecule from which side we have seen. So this will be our first and second priority. So we have seen that molecule from this side, left side. So in the left side, the methyl and hydrogen is placed. So methyl is above, hydrogen is below. And in the right side, there will be one hydrogen. So right side hydrogen is here. And in the methyl will be left side. So this one will be methyl. Now we have to find out the direction of rotation. So direction of rotation 1, 1, 2, 3. The direction of rotation is like that. So this direction is clockwise direction. So our configuration will be R configuration. So for that Allen system or axial chiral system, what is the rule? So we have to first see the molecule from left side, and after seeing that molecule, we have to place the substituent, the for which center we are first seeing. So this will be our first or second priority. Which center we are seeing last, this will be a third and fourth priority. Now we have to find out the rotation is clockwise. First, second, third is clockwise or anti-clockwise. If it will be clockwise rotation, then it will be R configuration, and if it is anti-clockwise rotation, then that will be S configuration. Similar things we can do for here. So we have seen that molecule from this side. So I will draw. So the drawn will be like that. So from this side, if we're seeing this molecule, the NH2 will be above, and the methyl is one the below the plane. This amine, so this amine is right side. So amine is right side. This amine is right side. So this one is right side. And the methyl is left side. So this one will be methyl. So first we have seen that carbon. Which carbon? This carbon one. So this will be first given priority wise. This will be first priority. This one is second priority. Next we have seen these two centers. So this will be third priority and this one will be fourth priority. Now we have to see that the rotation is clockwise and anti-clockwise. If we see this rotation, so the rotation will be anti-clockwise. So the configuration will be S configuration. So today's classes we have seen that Newman to Fisher, and next we have find out that configuration is R or S configuration. So thanks. So if you have any doubt, we can contact me like this mail ID. Any doubt happens in RS configuration. So we will meet in next week. Bye.